In biology class, a sample of bacteria was contaminated. After approximately 7 hours, the sample had reduced to approximately 2,000 bacteria. The students wanted to find out how many bacteria were included in the sample before the contamination. They found a function that models a declining population. T of x equals 1 divided by 25 hundredths times natural log of x minus natural log of 2,000, where T of x is the time in hours that the bacteria declined, the rate of decline is 25 hundredths, and x is the original population size of the sample of bacteria. Write an equation related to the function that would show the original population size 7 hours after the contamination. Then use a table of function values to estimate how many bacteria were in the original sample. Okay, so let's just look at our variables here. So T of x is the time in hours, and then x is the original population size. Okay, and so we first want to write an equation that would show the original population size 7 hours after the contamination. So we don't know x, we do know T of x. So T of x would be 7, so we could just substitute that into our equation there. So now that we have this function, let's go ahead and use a table to estimate how many were actually in the original sample. So we're looking for the x value here. And so what we can do is we can just go ahead and plug in our function right here into the y equals menu on our calculator, and that will actually help us make a table. We could do this by hand just by plugging in different x values, but let's just use the calculator to help us make a table, and I'll show you how to do that. Just note here also that after 7 hours, the sample had reduced to 2,000 bacteria. So in our table, we definitely know that the bacteria has to be 2,000 or greater, and so we're going to definitely adjust for that in our table in the calculator. Okay, so I've gone ahead and I've typed in our function into y1, and so now we're going to go to our table, so press second graph, and just notice here that at 1, 2, those are way too small population sizes. Remember, we're looking for the original population size, and we know that that can't be smaller than 2,000. And so to adjust our table to start at a much bigger number, I'm going to go to second window, our table set, and I'm going to have the table start instead at 2,000. And then because going by 1 when you're already at 2,000 is really, really slow, I'm going to try having it go by 1,000s, and we'll just see what that gives us. So now go back to our table, second graph. So notice now we can look here and we have our numbers in y, and remember that for y, we're looking for the hours. So we want to know 7 hours after the contamination. So we're looking for when y will equal 7. And so going down here, let's keep our eye on the y1 and see when that will equal or be close to 7. Okay, so we see that at 12,000, when x, or the original population, is 12,000, then y1 is 7 and 167,000, so really close to 7. And so that is, a really great approximation there. That's so close to 7, so we can go ahead and summarize our answer and say that the original sample size was about 12,000. The related equation is 7 equals 1 divided by 25 hundredths times the natural log of x minus the natural log of 2,000. In the table, the dependent value of approximately 7 is paired with the independent value of 12,000. If the rate of decline was estimated correctly, the original sample contained approximately 12,000 bacteria.